Great. Well, hi there, everybody. Thank you for joining us today. My name is John Burke, and I'll be moderating today's discussion on bonding ACM and thin-gauge metals with the use of Parker Lord's adhesives. Over the next half hour or so, we're going to be discussing the benefits of using these adhesives with and comparing to traditional methods like welding and mechanical anchoring. Before I get started, I want to introduce our hosts. I'm sure all of you heard Andrew here. He's our National Sales Manager here at Chemical Concepts. Joining him during the presentation will be Angela Zambonini. She's Parker Lord's Northeast Regional Sales Manager. And before I hand this over, I'm sure most of you heard this from Andrew, but we will be moderating the chat box as well as the Q&A box. So feel free to drop any questions there. So with that being said, Andrew and Angela, lead the way.
Thanks, John. Welcome, everyone. The topic of this discussion is improving aesthetics on thin gauge metals, plastics, and composites. So if you're a sign manufacturer that is often working with thin metals and pre-finished materials, perhaps you're an ACM fabricator manufacturing building facades, you've probably faced challenges when it comes to the visual appeal of your finished products. That could be dealing with exposed fasteners, distortion from welding, or read-through, which we'll be discussing as well. So we're going to cover these issues, how to prevent them, to arm you with the information you need to diagnose and identify problems and use the available tools and products to improve your results. So I'm going to just go through the agenda here. The agenda for today will begin with a comparison of adhesives with other joining methods, followed by a deeper look into the Bondline read-through, an overview of the Lord 810 and other acrylic adhesives, some discussion of bonding and powder coating, and then we'll share some available resources where you can learn more. Following the presentation will be the Q&A section to give everyone an opportunity to ask their questions to make sure that this is as valuable for everyone as possible. We'll try and get through the information as quickly as we can to leave as much time as we can for questions. So one of the biggest factors that is going to determine your performance and the visual appeal of your finished product is the joining method that you select. The most common options of welding, riveting, adhesives, and tapes each have pros and cons that need to be weighed as you are making decisions about various parts that will be fabricated. So to give you a better idea of which techniques might be most appropriate for different applications, I'm going to compare some of the most commonly used methods to the use of structural adhesives. So structural adhesives versus welding. Adhesives can be as strong or stronger than welding. We can bond mixed materials, such as different types of metals together without galvanic corrosion or dissimilar materials, such as metals to plastics. Welding can damage coatings, paints, and finishes. When you weld, you often need a secondary operation with a caulk to seal the part. With adhesives, you can bond and seal in one step. When we're talking about the aesthetics, we're often dealing with pre-finished metals such as painted metal, brushed aluminum, or mirror finishes, where the welding is either not ideal or not even an option. So then there's also the labor cost associated with welding itself and the post-work that comes with it. So although there are these advantages to structural adhesives compared to welding, I want to emphasize that adhesives do not need to completely replace welding in order for them to be valuable for your production. Welding is the right tool for many applications and designs, but welding and welders can be expensive. There's often additional rework, setup time, and other considerations that can add to the overall cost and or create bottlenecks. So the use of adhesives allow you to maximize the welders you do have and limit the welding to only the applications where it is really the best fit. So a lot of our customers are currently using adhesives and simply adding spot welding to certain locations as a fixturing device for extra strength. Let's see. And try and get to the next slide. There we go. See, is it frozen there? There, it's just taking a second. Okay. Rivets are another common joining method, especially in truck bodies. And a lot of the points here would also apply to any mechanical fastener. The first issue with mechanical fasteners is that they concentrate and localize stress on a small surface area. compared to adhesives, which distribute the load across the entire area of the joint. So this can increase the overall strength and prevent damage that might otherwise occur under load. As you can see at the photo at the bottom, rivets and mechanical fasteners can present issues with weathering, corrosion, and leaking as opposed to adhesives. So adhesives would eliminate any additional sealing step that would need to be done. And you can look at the photos of these two truck bodies. You'll see the photo on the left is covered in rivets, and the body on the right has a much sleeker design with fewer exposed fasteners. One of our customers actually uses the bonded body as an upcharge and the standard riveted body where they actually make higher margin on versus the bonded body. So, or versus the riveted body, I should say. So for them, it's actually a tool that they can use to upsell and increase their profitability. So perhaps that's something for you guys to think about. If there's any way for you to offer perhaps a mechanically fastened product at a lower price point and a bonded product with an improved visual appeal at a higher price point, that's perhaps a margin opportunity for you folks there. Liquid structural adhesives have some of the properties in common with high bond tapes. However, the structural adhesives will offer improved torsion resistance and fewer required stiffeners to achieve a similar level of stability. So this could cut costs and save time in production. Tapes are not usually repositionable, which can cause a problem. Liquid adhesives and tapes, when used together, can be a great tool and offer the best of both worlds, with tapes providing the immediate grab while liquid adhesive sets and while we're waiting for that set time to occur. So we've had a lot of success with this type of application. Using liquid adhesives can also allow you to use a cheaper tape, which can make the whole system, more economical. And you see that little animation there. So instead of structural adhesives, often adhesive sealants, silicones and caulks are used for similar applications. One component sealants will offer lower tensile and shear strengths, and you might need to cover a larger area. They will typically have a longer cure time, usually requiring some sort of secondary joining method to allow the part to the next stage of production without adding downtime. So similar to tapes, there are opportunities to use structural adhesives in conjunction with one component sealants, and there are certain applications where that could reduce the cost and improve the flexibility of the final part. So you've heard me make the distinction here between structural adhesives and other types of adhesives. The definition of a structural adhesive is on the screen here, and the key part of this definition is load bearing, which is usually defined as 1,000 psi in shear force. Structural adhesives are often two component. There are also one component epoxies that are heat activated, and some products can be pre-mixed and frozen, but that's not as common today. Mostly you're looking at two component adhesives when you're talking about structural adhesives. There are many types of non-structural adhesives, but for our discussion, we're mainly talking about sealants and tapes. So with that, here is Angela Zambonini with Lord Corporation, and she's going to talk about Bondline read-through. Angela?
Thanks. So just going back to the previous slide about structural adhesives, the reason why you wanted to make that distinction is because Lord Adhesives manufactures structural adhesives. They're designed for really harsh, tough environments, and the product in specific that we're going to be talking about today is the Lord 810, which is for Bondline read-through. So what is Bondline read-through? Bondline read-through is a condition where you can see the footprint of the adhesive through the material. To give you a visual of what that looks like, there's a picture in this slide. Essentially what we did was take an ACM panel and bond it with both a competitive adhesive as well as the Lord 810. And to the left, you can see essentially waviness, which is caused by the competitive material. Whereas you don't see that same effect on the right, which has been bonded with the Lord 810 load read-through. So now let's look at why read-through occurs. Well, read-through occurs because, especially on ACM, which stands for aluminum composite material, it's essentially two thin sheets of aluminum that sandwich a polyethylene core. Now, when an adhesive cures, sometimes it gives off heat, and sometimes that heat is so great that it melts that polyethylene core. And as the core softens, it expands. And then the adhesive, once it's finished curing, it then cools and the core shrinks back, pulling the aluminum with it. And this shrinkage kind of creates a pulling effect on the bonded materials, which is why you see a rippling or the footprint of the adhesive on the back side of the panel. That's why read-through happens. Now, the materials that are subject to read-through are, if you can go back to the last slide, the materials that are subject to bondline read-through are thin gauge metals that are less than 0.010 of an inch thick, have a high gloss or a high polish or even a mirror finish. And then one thing we did want to note is that the larger the panel or the darker in color it is, the more exaggerated that read-through effect tends to happen, especially when it's reflected into sunlight. So essentially, when you have the larger the panel or the darker the color of the panel is, the more read-through you could potentially see. Next slide. Now, why is preventing read-through important? So you work really, really hard to design products that not just perform, but look great as well. And the last thing you want is to see a distorted or deformed appearance. Overall, preventing read-through is important because you can improve your aesthetics. So here's another example of what read-through looks like. What we've done is bonded a bracket to ACM, which is essentially for architectural cladding, which I'll talk about more in another slide. Again, we bonded it both with a competitive acrylic as well as the Lord 810. When we then took those panels and reflected window blinds on each of them to see how their reflection would look after the adhesive has cured. And as you can see on the left, the window blind reflection is wavy, indicating how much the adhesive is distorting the area on the other side. You don't see this on the Lord bonded panel. Instead, you just see a nice, smooth window blind reflection. Now I'd like to introduce the Lord 810, which is the solution for bondline read-through. And as of today, the Lord 810 is the only solution on the market that specifically targets and works to reduce or even eliminate bondline read-through. So the Lord 810 is a two-part flexible adhesive. And I'll say flexible because it's nearly 3 times as flexible as some of our other traditional acrylics, which really helps to move and expand with ACM and other thin gauge materials, even with materials that might have a different CTE. So materials that might expand and contract at different rates. So that high flexibility is why the Lord 810 is so successful at eliminating read-through. It also doesn't have an exotherm, no shrinkage, and it could bond to a wide variety of materials, including metals, painted metals, plastics, substrates, and it could cross bond to all of these. The Lord 810 sets up very quickly, so you got about 8 to 10 minutes to work with it, and then in just 20 to 25 minutes, you can unclamp your parts and send it along the way into final assembly or further along the line. The other great thing about this product is it can survive e-coat and powder coat. So we get that question a lot. Can your adhesives go through powder coat or e-coat, or can they go through a bake oven? Yes, they can. Now, some advantages over other technologies include they're more cost effective, they have really great tensile and peel strength, and again, that improved aesthetics. So little to no read-through. Some other applications for the Lord 810 outside of just ACM, because again, it could bond a wide variety of materials. You can use it in aesthetically sensitive applications. Architectural cladding. Architectural cladding is bonding brackets onto ACM panels and then fixturing those brackets to sidewalls that you'll see in a car dealership, hospitals, and other commercial buildings. You can also use it as in stiffeners, as well as on thin gauge metal and plastics. Another application for the 810 is in areas that have really critical peel strength requirements, such as high wind load applications. The wind puts the bonded area into peel, which is not really great for adhesives, but with a really flexible and strong adhesive, the 810 does really well there. You can also get throughput improvements as well. So any areas where you need to have a faster cycling time. The 810 works really great there as well. And I have a great case study which talks a little bit more about improved throughput that I'll go over in a couple of slides. So these are the two big case studies that I want to go over with today. So the first one is with Firestone Building Products, which is where we first discovered what Bondline read-through was. Firestone wouldn't let us share pictures of their jobs, so I just kind of took these from Google just to give you an idea. The pictures on the right are of architectural cladding, again, which is bonding ACM to metal brackets and then fitting those metal brackets to a sidewall. This is purely aesthetic. It doesn't have any form or function to the building. It's just to make it look nice. So when we started working with Firestone Building Products, the adhesives were causing that rippling, causing that distortion. So what we did is we formulated a highly flexible acrylic adhesive that could bond very, very well to bare metal, but also move and expand and not give off so much heat when it cures. And so that's where we formulated our Lord 810 and also our SignLock 810 products. And the other great thing about this with Firestone Building Products is they were previously anodizing their aluminum. Well, they completely got rid of that because the great thing about Lord products is they bond and seal in one step. They'll provide corrosion resistance and environmental resistance. So there's no needed, there's nothing needed additional to offer corrosion resistance. So they ended up saving themselves some time and money by removing the anodizing out of there. Now, the second case study I wanted to go over is one with one of my truck customers, which is a picture that we've shown in a previous slide before that Andrew briefly mentioned. But just to go in a little bit more detail, so this is one of my truck body customers, and they offer both bonded and riveted truck bodies. And you'll see on the left that there's a lot of waviness and distortion caused by the rivets. And that's the rivets puncturing into the sidewall and causing it to ripple and deform along the whole side of it. Now, if you look to the right, this is actually one of their bonded bodies. And you can see the reflection is nice and smooth. You don't have any exaggerated ripples or waviness. It's a really clean finish. And the great thing about this setup is improved aesthetics. It looks nicer. So this customer actually offered the same exact truck, just bonded, at an upcharge, which meant more margin, more profit for them for the same exact truck. And this is the potential that you have as well. For the same designs that you're working with, you can use alternative technologies, improve your aesthetics, and ultimately make your businesses a little bit more profitable. The other thing that I wanted to mention about this case study is throughput. So I mentioned that the 810 is really great for areas where you need to make sure that you're going quickly. Well, this customer was using a slower curing adhesive. It took them about 6 hours just to reach enough handling strength. So what we did is we introduced the 810, and because of its fast cure time and its fast handling time, they were able to cut their tack time down from 8 hours in total down all the way to less than an hour, which meant that they can manufacture anywhere between 4 and 6 trucks per day in that same area, which completely eliminated a bottleneck. Another benefit of working with Lord adhesives. Now I'll pass it back over to Andrew, who's going to give you a little bit of a how-to guide on using adhesives.
Sorry there, I had to unmute for a second. Thanks, Angela. Now I'll take you through the steps on using the 810 to bond ACM. So there are essentially 3 steps, which is to clean, prep, and mate the parts, which includes, clamping and fixturing as well. The first step is to clean the parts to be bonded. Lord acrylic adhesives have the advantage in requiring very minimal surface prep required in order to get a good bond. The recommended cleaning procedure is to use a clean, dry rag just to wipe the surface, followed by a surface wipe. We recommend IPA or isopropyl alcohol. Acetone can be used as well. A light sanding with a non-woven abrasive product like 3M Scotch-Brite or similar. There's similar constructed abrasives on the market that act the same way. And then a final step is to remove the sanding dust, which can be a dry rag wipe, an additional dry rag wipe, or you can blow off the surface with compressed air as well. If using cartridges, the next step is to prep the adhesive. So the cartridge is inserted into the gun. If you have an adjustable gun, you want to make sure that it is set up for the correct ratio. The Lord 810 is a 2-to-1 ratio product, so you want to keep that in mind if you have that adjustable gun set up. You want to remove the cap and dispense a small amount of adhesive until the adhesive is coming out of both sides. So if you see the picture on the left, the reason we do that is you can see out of the factory, they fill up the one side of the cartridge, it's moved to somewhere else, another operation, and then the other side of the cartridge is filled. So there's often a slight discrepancy of one side or the other will have an additional adhesive. By doing that check to make sure that you're having both components coming out of the adhesive at the same time, you're ensuring that you're getting the proper mix. Next, you want to apply the static mixer and dispense a bead of adhesives approximately the length of the static mixer. That also ensures that the product that you're actually using on your part is mixed appropriately. And then you always want to check and see the mix ratio. The next photo over, shows some discoloration where you can kind of visually see that some issue occurred with the mix. So you want to make sure, verify. That's another reason that you run out of bead, that you can kind of check that bead later and make sure that everything is curing properly and do that visual check. And then at this point, you're ready to apply the adhesive to your part and continue on. So you can see that discoloration is being highlighted there. So the final step is to actually make your parts and fixture them somehow so that they don't move until the handling time is reached. So as Angela mentioned earlier, the 810/20 has 8 to 10 minutes of open time and requires 20 to 25 minutes of clamping time until that handling strength is achieved. So once that handling strength is achieved, at that point it's ready to move on to the next operation. But do keep in mind that the adhesive will still take a full 24 hours to reach full cure. There are many clamping methods that can be used by themselves or in combination. Any of these clamping methods that are on this slide can be effective. I would actually add tapes to this as well, which I mentioned earlier, which can be a great option to very quickly get the immediate grab of the tape and then use the liquid adhesive as well. So another important consideration for reducing read-through and maximizing performance is to create a consistent bondline thickness throughout your joint. So you want to make sure that whatever weight or pressure that you're using is applied evenly. If you're using weights, you want to make sure that a similar weight is used on one side of the panel versus another. You wouldn't want to use a 20-pound weight on one side and a 10-pound weight on the other. You want to make sure that that pressure is applied consistently across the part. And the result that you're shooting for is a 0.010 of an inch bond line, which is the optimal thickness for strength. High and low spots can become stress points, and uneven clamping or over clamping can also damage the panel or create distortion in its own right. So here's Angela again to take us through some additional considerations when using Lord adhesives. Angela?
Thanks. So again, Lord manufactures structural adhesives. These are adhesives used for load-bearing applications. And the Lord 810 isn't the only acrylic adhesive that we have in the market. We actually have 4 different product lines in the acrylic chemistry. So the first one is MaxLock. MaxLock is our superior heat resistance, environmental resistance, and strength adhesive available today. It works really, really well on stainless, galvanneal, and galvanized steel. And again, it's really because of its higher peel resistance. So that's another feature of the MaxLock. It's higher peel resistance. Because of that, we do recommend it for higher wind load applications. And we offer it in 3 different cure speeds, which make it really great for fitting your ideal process time. So that's the other great benefit that you'll get with working with Lord, is that you don't ever have to convert your processes to our technology just to be able to use adhesives. Rather, when we manufacture adhesives, we like to do it the other way around. We like to manufacture 1, 2, 3, sometimes upwards as many as 6 different cure speeds so that you have options to choose from to fit your existing processes rather than having to change them around just to use new technology. So the next product I'll talk about is the Lord 400 series or the SignLock 400 series, depending on what you're familiar with. And these are our most popular Lord acrylic adhesives. They're our go-to because they'll cover most applications. You can cross-bond a lot of different bare metals, plastics, composites, as well as painted metals. And it's got proven performance for over 40 years. And it's similar to the Max Lock. It cures, it's got 3 different cure speeds, basically slow, medium, and fast. The next product is our latest technology for acrylic adhesives. It features improved fatigue resistance, which is really great for tough applications where the adhesive bond may be getting really beat up on, say for example in service trucks. It offers higher heat resistance as well, just like the Max Lock, and it is by far our best cross bonder to date. So if you are using a lot of materials in your plant and you maybe just want to carry 1 or 2 SKUs instead of having a bunch of different SKUs to choose from, you can start with the LORD 850 because more likely than not, you'll be able to bond to a wider variety of substrates in your plant. The last product I'll talk about is the LORD 201. This is different from the other 3 adhesives that I just mentioned because it's our no mix solution. But what I mean by no mix is that you apply the adhesive on one substrate and then you take the other part, the accelerator, and apply it to the other substrate. And then you can trowel this, you can get full surface coverage, which is why some customers like this, but then you also have unlimited open time. So the adhesive won't start curing until you put the 2 materials together and they touch, and that's what starts a chemical reaction. So, so those are the 4 different products there. Again, these are really great cross bonders. You don't just have to use them or fit them into working with metal. They will work with other substrates in your plant. Most of these products also come with glass beads, which I'll talk about in the next slide. This 400 series has that UL 746C approval, especially if you're in the sign industry and need this. And the shelf life for all of these products is 9 months, so pretty decent shelf life. So now the difference with LORD Acrylics is our glass bead technology. And we suspend glass beads in our materials for 2 reasons. One, to reduce over clamping. No matter how hard you clamp down, you're not going to squeeze out all the adhesive in there. So some issues that maybe newer customers or newer shops run into is they'll have somebody come in with Popeye arms, really, really strong, clamps it down as hard as they can, and then they squeeze out all the adhesive that they just laid down. And then the part fails and they wonder why it failed. Well, because there's no adhesive in there holding anything together. So we put glass beads in between, within our material so that you always get that ideal bond thickness. Now, the second reason we put glass beads in our material is to minimize galvanic corrosion, which is the corrosion that occurs between 2 dissimilar metals, say for example, aluminum and steel. The tiny glass beads act as spacers, ensuring that the 2 materials don't touch, which is how we're able to eliminate or reduce the galvanic corrosion when multi-material bonding. Now, one common question we get all the time is, can your adhesives go through powder coat? And yes, for probably the millionth time this season while we've been in the coronavirus, yes, you can put our adhesives through powder coat. And if you want a more detailed guide on what this looks like, a how-to guide, we do have a video, or a course I should say, on demand that shows you exactly how to do this. But just in general, you know, we'll go over some highlights here. And I do want to say we actually do prefer bonding to the bare metal and then sending it through the oven rather than bonding to the paint. You just get a little bit more of a stable bond that way. So let's talk about bonding before powder coat. Now, the adhesive that we recommend for bonding before powder coat are these 3 options. We have the Max Lock, the 400 series, and the 810, which we featured in the earlier slides. They all have temperature resistance of 400 degrees Fahrenheit or 204 Celsius up to 90 minutes. So you don't have to worry about the bond line degrading as it goes through the oven. Another great advantage of LORD Acrylics is they will come out even stronger out of the oven than they would be just curing at room temperature. And this is a unique property of our technology. So Max Lock is our top performing adhesive for powder coat just because of its superior temperature resistance and tensile strength relative to our other acrylics. You will want to use this adhesive if you do have really, really large or really heavy parts, or if you're using steel and you're using metals such as especially galvanneal or galvanized, as it gets really, really good performance on those. And you also want to consider this adhesive if your oven temperatures are 350 or higher, and if you have longer bake cycles. The next one is the 400 series. Again, it's just, it's a really great option. Most customers are using the 400 series, so you'll still get really great performance. And then similar to the Lord 400 series is the Signlock brand, the Signlock 400 series. This can go through the powder coat oven as well as the E-coat oven. And if you're wondering what the difference is between the Lord 400 series and the Signlock 400 series, they're essentially the same thing. You're gonna get the same performance. The only difference you get is the benefits of the Signlock packaging. So you can find these both at Chemical Concepts, and if you need a recap on what the differences are, Chemical Concepts will definitely be able to walk you through that. But essentially with the Signlock packaging, you get 2 free mix tips per cartridge. All the Signlock products will fit the same gun. So if you like the Signlock 8, or if you like the 810 product and you like the 400 series and you want both of them, they'll both fit the same gun if you get the Signlock brand. And then you also get some added shelf life as well. So with the Signlock packaging, you get 18 months shelf life instead of the 9 months that you get with the Lord product. And then again, the last one that I'll go over is that Signlock 810. This can go through the powder coat and E-coat ovens. Like I said, the Lord 810 or the Signlock 810, it's the same thing. And we even actually recommend it for Kynar bake cycles, which could get up to 500 degrees Fahrenheit. So it'll work there as well. Okay. Now this is an example of another customer that I work with who is bonding after powder coat. So now these are the adhesives we recommend if you prefer to bond after the powder coat, which sometimes for some processes, it works better that way. So you can use the Maxlock in the 400 series for both before and after powder coat and E-coat, which really makes it great to have as a product in your shop because it can do both. It could also cross bond as well. So if you wanted to bond bare metal to painted metal, you could use the Maxlock with the 400 series and without surface prep. Different from the 400 series and the Maxlock are the 7542 and the 7800 AC. These are our highly flexible structure adhesives, and they're used in a wide variety of applications ranging from roofs on truck cabs to a sign assembly. They're known for gripping very, very well into paint, and our 7542 is one of our most popular urethane adhesives, and it comes in 3 different cure speeds, just like the Maxlock and the 400 series. Now the 7800 is our newest urethane technology, and I'll talk more about that on the next slide. The 7800 is a urethane adhesive designed to bond plastics, E-coat, powder coat, all kinds of different surfaces, coated metals, composites, SMC, and it cures really, really quickly. So the great thing that caught on with acrylic adhesives is they have decent open time, but their handling time is so quick. You can reach 1,000 PSI in minutes. The great thing about the urethane adhesive, or this new 7800, is that it behaves just like an acrylic. So in less than an hour, you'll have 1,000 pounds per square inch of tensile strength, which means that you can really move quickly when you use this product. The other things that we added with this urethane is we've added a UV tracer in case you're using dark panels or putting it into boxes and it's difficult to see if you've properly sealed everything. So we put a UV tracer in there to help automate if you want to use a robot, or if you want to just go in there by hand and use a black light. The other difference with this adhesive is it's GM spec approved as well. So it went through that GM automotive spec for bonding plastics, which really just shows the level of environmental resistance that our adhesives get. Now, the last thing that we'll go over is just some joint design. When using adhesives, you really want to make sure that you're trying to design for as much surface area as you can. The greater the surface area, the stronger the bond is going to be. We like to try and aim for at least an 1/8 inch bead, which kind of squishes down to about 3/4 of an inch to a 1 inch overlap. And that'll just really ensure that you have a lot of good strength in there. And you also want to make sure that you design for shear and compression and try and avoid peel when possible. And so, you know, looking at this, I don't want you to all feel overwhelmed either. We have a ton of great resources, both at LORD and at Chemical Concepts, to help you out. So don't ever feel like you have to do the designing or choosing of the proper adhesive completely on your own. So you're always welcome to reach out to us anytime for help with your applications. And so we'll just go through a couple of those resources on the next slide before we open up for questions. So again, you can go to our website, lord.com. If you're a sign shop and you really want to know more, we have a landing page just for signs. So you'll just do /sign, and that'll take you all of our great resources. We also have a lot of blog posts and things on LinkedIn, Twitter, as well as a lot of how-to videos, on-demand courses, all on our YouTube page. And then if you would like more information, you could also give our hotline a call, 1-877-ASK-LORD. Our wonderful folks, Gail and Carolee, are on the phone or are on the call today. If you do call in, you'll likely get one of those wonderful ladies. And then if you do prefer just email, I've got my email listed as well as Andrew has his listed. And then before I transition to giving Andrew and John the opportunity to talk about some of the other resources to help you out, I do want to let you know that we do have a promotion going on for the LORD, or for the SignLock 810. This is not the LORD 810, this is the SignLock 810. So if you are interested in what you learned about today, you want to maybe give the SignLock 810 a try, or if maybe you're already buying the SignLock 810, this is a really great opportunity for you to stock up on some guns. So our promotion is buy a case of SignLock 810 and get a free gun. And you can get up to 2 free guns for that. So if you want information, please reach out to your Chemical Concept rep and they'll be able to help you out.
And to kind of echo Angela, we have some of our contact information on the page right here. We're going to be sending an email out after to the attendees with some additional resources and the recording from the event today. And with that, I'll pass that to John so we can kick off the Q&A.
Thanks, everyone. So I hope everyone learned a little something there. With that, I do want to introduce Carolee Nail and Gail Rakowski from Parker Lord's technical team. Hello there. And any questions you have, feel free to drop them in the Q&A section or in the chat box. I'm sure everyone has plenty of them. I do have a question I know I get asked a lot. As far as bonding indoor and outdoor, what are the different considerations you might take as far as product is concerned and what to use?
Mm-hmm. So one question, and I'm sure Gail and Carolee also have some really great input on this question as well, but with indoor and outdoor applications, one thing to consider is definitely the temperature in which you're bonding. If it's really, really hot out, that could cause the adhesive to cure quicker. So you might have to, you don't want to feel rushed. So you might have to go to a slower curing adhesive. But also if it's really, really cold out, we recommend that you try not to bond in an area that's below 40 degrees Fahrenheit because you might delay the cure so much that it might not cure at all. So just be conscious of that. And then also be conscious that if you are applying it in the cold or outside, just make sure that you keep them clamped for a little bit longer because it's going to take a little bit longer to cure.
Great, thank you. Another one I see here, it's a question on the large pieces or the large panels. And you mentioned it briefly, but can you review what kind of options the customer has if they're doing huge, big sheets or they're laminating or something along those lines?
Mm-hmm. If they're laminating, we recommend that you use more of a full surface coverage adhesive, something like the 201, just to allow yourself to get that full surface coverage. If you try to kind of trowel or roll out or brush out some of our other adhesives like the Max Lock with the 400 series, you can introduce air, which could ultimately have a negative effect on your bond performance. So if you are trying to get full surface coverage, we do recommend using more of our laminating adhesives like the 201.
great. Thank you. Thank you. Another one I know I get all the time is cross bonding dissimilar substrates.
Mhm.
Is there some sort of reference guide or anything a customer can use, or?
Yes.
Sure.
Good question. So we do have a cross-reference tool on our website. You could find that at lord.com. You could also find it in the resources tab on lord.com/sign, which is our cross-referencing guide. And essentially it'll list a bunch of different substrates on the left, and then a bunch of different substrates on the top. And then the way that you read it is you find the first substrate that you want to bond to on the left and follow it over to the right until it crosses with the substrate you want to bond to. And that'll give you kind of a good starting point on where to go. So for example, say you were trying to bond, acrylic to aluminum. Well, you could follow it over and see that we recommend one of our acrylic adhesives or one of our urethane adhesives if it's painted. And again, don't feel like you have to, you solely rely on the chart. You can reach out to myself or reach out to Gail or Carolee on our hotline as well for some application help.
Excellent.
Another question here from Jason. He asked, shall Lord 810 be held to 1 psi for sustained load or creep?
I'm sorry, say that one again.
So shall Lord 810 be held to 1 psi for sustained load? Which if I'm reading that correctly, is that kind of just holding it in place while it reaches its handling strength? If you're on a vertical, will it sag? That's the kind of way I'm reading that.
I see. So so with the adhesive, it's not like it's pressure sensitive. You don't have to put pressure on it in order for it to cure or to react. So tape is held to download. I just saw another comment from Jason.
Right. So I think he's talking about the specification. So long term, what kind of download can the adhesives handle? I mean, I know that the Dow 795 is again an adhesive sealant, which is not really going to be in the same ballpark in terms of ultimate strength, and the tape neither. So I mean, even a typical adhesive, I don't know exactly what the spec on the Dow 795 is, but to speak in generalities, when you talk about either tensile and shear strength, you're talking about usually less than 1,000 psi, usually 3 to 600 psi, something like that. Where for a structural adhesive, you could be in the 2,000 to 3,000 range.
Right. And for the 810 on aluminum, most of our studies are about 1,000 pounds per square inch. So that's just 1 inch, and that will hold 1,000 pounds of load and lap shear. Essentially, right. The panel is moving this way or moving this way. And
I know tapes are more susceptible to creep because you really have a pressure sensitive type of bond rather than a chemical bond. So I know that maybe Carol Lee or Gail can comment on the numbers, but I know there definitely would be less creep, or I don't know, would you say that it's zero creep, or does Lord have anything on creep in terms of acrylics?
This is Gail. I don't know if creep has been calculated for the 810. I know it has been calculated for the 400 series. If Jason, if he has an email, or if you would like to send in a contact us to us, we can certainly look up that information. I do know there was a video out there at one time that demonstrated the creep resistance of the 400 in comparison to the tape, and it was over a period of a couple weeks, maybe 6 weeks. And by the end of that time, with the weight on it, the 400 series had not given up any of its strength, whereas the tape had completely come undone. So, like Andrew said, the adhesive chemically etches into the aluminum, which gives you that extra strength and higher strength cross-linking, and it usually is not a problem, not like you think of tapes where they kind of creep and then they eventually get a little stringy or just pop off. But yeah. Jason, if you want the information, we can see if we've done anything on the 810. If not, certainly we could push over some of the information from the 400 series or even the Max Lock.
Yeah.
Okay.
I would, yeah, I'd expect the dead load to be much higher than what's listed for the Dow 795. And but like Gail said, when we have your email address, we could send you some more data that we might not have available right in front of us at this moment. But to just a little bit more context, I mean, structural adhesives, when we talk about that word structural, I mean, these are being used, in long-term load-bearing applications such as, vehicles, even in aerospace and stuff like that. So these are certainly designed to hold for a long period of time at values higher than 1 PSI for sure. But we'll get you some more specific information that you would need. I see you're with an engineering company, so I'm sure you want real specific numbers. So, but thank you for the question. Sorry, go ahead. John, were you going to get to the, I see we have a couple other questions here.
Yeah, so I have a question here from Jim. He's asking, could you use the 810 to directly apply ACM to masonry such as brick?
So I'm not sure about that one. Gail or Carolee might be able to comment, but if a porous substrate's involved, something that's like a masonry, like a stone, ceramic, we actually recommend one of our epoxies just because they grip really well into those porous substrates, and they could bond to metal as well. So if you are looking to cross bond metal with masonry, we might have you look at the 360 epoxy or the 320, 322 epoxy.
Yeah, and that's another situation where if you have a specific application that we can help you with, feel free to provide an email address, or like when you get the we're going to be sending an email after this, which is going to have a contact link on there. So if you could ask, get in touch with us, start a conversation, and we'd be happy to give you some engineering resources to help you select the right product or combination of products for what you're trying to do. To kind of echo what Angela's saying, yeah, the acrylics tend to not be as good porous substrate bonders as good for masonry. The epoxies are preferred, and then I know a lot of times people also want to see a certain amount of flexibility for a dissimilar substrate if you're trying to direct apply to masonry. So you probably want to have some kind of movement capability. So whether that might mean an epoxy in combination with a liquid sealant, or using a liquid sealant or something like that. So those would be the kinds of things that we would look at. But yeah, feel free to contact us, and we can work with you on a specific application. But great question.
Yeah, Andrew, this is Gail. We frequently get calls in for for bricks or masonry. If the application is light, if they're not heavy signs or heavy plaques, we would recommend the 7610 BTM. And that would, we'd recommend a light scuff on that ACM.
Right. So that 7610 is a one component adhesive sealant like we were talking about earlier, and that would really give you that more flexibility where, hot day, especially where we're looking at, if it's, somewhere in the Northeast, for instance, where we're at, we have hot summers, cold winters. You want something that's going to have some amount of expansion capability. So that's a great option that Gail proposed of the 7610 product.
Great, thanks guys. I got another question here from Ben asking if the surface prep and adhesive needed for ACM to aluminum tubes, and he mentioned the 7610 in there. What would you guys recommend typically?
I'll take a stab at that. So I think the surface prep for ACM to aluminum tube would, aluminum is something that we bond pretty readily, and I wouldn't expect anything different than really the steps that were mentioned earlier in the webinar. So really a dry rag wipe, an alcohol wipe, some light abrasion, and then you need to clear off whatever that remaining dust would be. Same thing on both sides of, which is, when you're talking about aluminum tubing and then an aluminum composite material, you're basically bonding aluminum to aluminum. So depending on what the application is, whether we go with an acrylic such as, the Max Lock or even the 810, probably the 810 would be the go-to if your objective is to eliminate and prevent read-through like we've been talking about. The 7610 would also be an option where, having that same high level of flexibility being a one component. And like we were saying earlier, comparing one components to two components, you're not going to be in the same ballpark strength-wise, but we try and engineer things for the application that we're working with. So if the kind of strength that a two-part structural adhesive, if that's not required, then you can use the 7610 product. If you want the highest strength possible, you'd probably go with the 810 product. And you know, if again, if you have a specific application in mind, we'd be happy to talk through it more specifics and say, yeah, I'd actually go with the 810 in this case, or no, I think you'd be okay with the 7610. But the 7610 product is a hybrid kind of technology where the surface prep steps would be more or less the same to what we described for the acrylic technology. The hybrids bond very readily to aluminum and other smooth materials like that, and just adding a slight scuff with a Scotch-Brite really prepares the surface very well for bonding. So I think you'd be in good shape with those steps that we provided.
Great, thanks, Andrew. Another question here was just on the static mixers, the mixing nozzles. Typically, the cartridges do include one, but I was told that the shine lock includes two, correct? Two mixing nozzles?
That's right. Mm-hmm.
Okay, great. Another question here is metal studs, plastic studs for signage. Is there a preferred adhesive for whichever type of maybe glue-on stud you have?
So it pretty much just depends on the materials that you're bonding together. So if it's a stud going into, you know, a stone type material, we'd probably recommend one of our epoxies. If you're bonding a metal stud to a metal sheet, you could look at our acrylics. Especially in the sign industry, the sign lock products are a really great place to start, especially with the promotion going on right now. So it just matters what materials are trying to stick to, and that's going to determine what adhesive we recommend. But
Yeah.
Typically for sign, it'll probably be one of our acrylics or one of our epoxies for bonding in a stud.
Yeah, and if read-through is your number one concern, and it is an ACM kind of product, then the 810 would be where your mind would want to go.
Great, thank you. Another question, how do you estimate how much adhesive you need for a job?
Good question. So we do have a guide online about recommended bondline thicknesses, but for most construction applications, we try to make sure that you aim for at least a 1-inch overlap. So in order to get that 1-inch overlap, like of a squeezed out area, we recommend dispensing at least an 1/8 inch bead, because when that squishes down, it squishes down to about 3/4 of an inch to an inch. But to kind of help gauge how much strength you'll need, if it's not as much of a structural or load bearing type application, you might be able to get away with a little bit of a less overlap. But just work with your engineers to figure out how much strength you need, and then you can kind of gauge it that way. But at minimum, we like to see at least a 1-inch overlap of adhesive.
The other thing that you can estimate is for just a rule of thumb is that you'll get about 5 linear feet out of every 50 mil of material, of adhesive material. So if you're trying to estimate how many cartridges you'll need for a job, that's just kind of a rule of thumb that we use. And that's 5 linear feet at about a 1/4 inch bead.
Yeah. So to kind of piggyback on that, depending on what kind of surface area you need to cover, I kind of think about how many beads, say you're doing lineal feet, but you got to do, say glue two 3-inch profiles together. So you might assume for a 3-inch profile, you might apply 3 linear beads across the surface to cover the whole surface area. So then I would just multiply that number times 3. So to cover 3, you got to assume that a 1/4 inch bead, when you compress it, is going to squeeze out and cover a certain area. So that's kind of my way of converting to linear feet in my head from surface area. So if I know I have a 3-inch wide by 6-foot run, I'm basically it's the same as doing 3 6-foot runs of a 1-inch bead. Or a 1-inch width. So that's kind of a little trick I use. Hopefully that kind of made sense. But when you have to do a thicker area, you can always kind of multiply that by the amount of beads it would take to cover that width. Hopefully that was clear.
Another question is, let's say, storage, and if you have cartridge with adhesive left over, what's the correct process you should use?
So if you partially use an adhesive, that's okay. You could still use it the next day or a couple weeks down the road. Essentially, you have the shelf life of that product. Just ensuring that you leave the mixed tip on there, and that will be your new tip. So as long as you leave the mixed tip on, it's sealed up. You'll just have to come in the next day or the next couple days, whenever you're ready to use it again. You just take that old mixed tip off, put on a new one. Dispense a little adhesive out just to make sure you've got all the thick material out, the partially cured stuff, and then you're good to go. And then storing, we recommend, especially if you're going to be using the adhesive relatively soon, we recommend that you at least bring it up to room temperature, because I know some plants could get really hot or really cold depending on the time of the year. So we recommend that you try and, don't leave the adhesives outside, try and store them in temperature controlled environments, try to keep them off the floor. And then when you're ready to use them, make sure you definitely bring it into a room temperature area so that it's easy to use and ready to go.
Angela, let me add something in too in regards to starting, if you're saving some of your 810, you have some 810 left over and you store it on the shelf. That product is very sensitive to some cross-contamination, and it will have a tendency to have almost like a, I guess Chemical Concepts understands when they talk about almost like feels like a rock, or it looks like a rock or something on the one side of the cartridge. And so it's really important that you purge that. You level the plunger, should I say, that you put it in the gun, you dispense it, make sure it's coming out both sides equally, and then go ahead and put on your mixed tip. The 810 is very sensitive, that, and we have people who have been off ratio and had problems with bonding, so we want our folks to pay attention to that.
Thank you. Great point.
Yes, we have a question here from Carlos. Is there a limitation in height and width covered for an ACM panel design? So I think he's talking about basically what is like a maximum size for an ACM panel that you could glue. And the first part of his question said about gluing aluminum tubing to ACM. Am I understanding you correctly, Carlos? You're saying, is there a maximum size panel total? Okay, and I guess I'm imagining, so you're doing an ACM panel and you have a aluminum tubing perimeter and then maybe aluminum tubing stiffeners. Is that kind of what you're talking about? Yes. Okay. Any information there in terms of a maximum size?
There really isn't a maximum, especially just the larger the panels are when you're moving them. Just be careful not to kind of twist and move them while they're curing, because you could get some seams that pop. With the larger panels, you might need greater surface area. So again, that's something to make sure that you calculate, work with your engineers on making sure you have enough strength in there. So some of our customers who do have very large parts, I have take the example of trailer. They're very, very long trailers that could be up to 50 or 60 feet long, bonding various components. So for them, they actually target a 1.5 to a 2-inch overlap, and that's the whole way across the panel or across the roof or the floor, whatever it is that they're bonding. So so for really, really big parts, again, calculate it out, but you might want to target a larger bonding surface area just to make sure that you do have enough strength in there. But other than that, no maximum on the size of the panels that you could be working with.
Excellent.
Great. I think I'll keep it open to if anyone wants to drop another question or two here while we have a few minutes left.
I think one last question that just popped up, John. It looks like Salim. Oh, Salima, I'm sorry. She missed the presentation. Are you going to be posting a link to it or a recording?
So everyone who registered will get a on-demand link, so you can watch this after the fact. For those who had to drop off for whatever reason, or you came in late, feel free to look out for that. We'll hope to get that out by tomorrow morning if we can, but sometime tomorrow for sure. So.
Perfect. Thanks so much for coming, Selena.
Yeah.
Great. Any other questions while we got a minute here? Keep it open.
I think that's it.
I think that's it. Okay, well, thank you, everyone. Thank you to the panelists, Angela and Andrew. It was great. Anybody who needs to check out some more information can go to lord.com. Anybody else can go to our website, www.chemical-concepts.com as well. Plenty of information there. You can always call any of our offices. Our technical teams are here to help. And with that being said, thank you all so much.
Cool.
Thanks,
And special
everyone.
thanks to our tech service team, Gail and Carolee, for joining us as well.
You're welcome. Thank you.
Thank you.
Thanks, everyone. And thanks to you guys at home or at the office for joining us. Really appreciate it. And we're here. Hope to talk to you everyone soon. Thanks.
Thank you.